I want to welcome everyone to the talk, Continuous Improvement of the CI Ecosystem in Julia by Anant and Elliot.
Hello, everybody. My name is Elliot Saba.
And I'm Anant.
We both work for Julia Hub, and we're going to be presenting on Buildkite CI and the Julia ecosystem. Some of the work that we've been doing over the past couple years, actually, and all the ways that it can benefit you guys in your own pipelines. So first off, a little bit of background about Buildkite CI and the Julia ecosystem. So base Julia CI needed an upgrade a couple years ago. We looked around at the different options and we settled on Buildkite. It took us about 2 years to move from the old CI system, BuildBot, to Buildkite. And over the course of that, we developed a whole lot of functionality. We developed modular plugins that you can use in the different CI pipelines. And we also extended Buildkite to not just serving base CI, but many ecosystem packages such as SciML, libloss trampoline, sweet sparse, etc. Buildkite pipelines, in case you're not familiar, are typically defined by YAML files that live in your repository. So you define how you build your software or how you test your software right alongside the software itself, which is a very familiar concept for anybody who uses GitHub Actions or Travis or anything like that. In particular, however, for Buildkite, they don't offer agents, so they have to run on your own hardware. So you set up a Buildkite agent somewhere on your own hardware, and then it does the downloading, installing, testing, etc. Just to give you a quick demonstration of what it feels like to build a new Buildkite pipeline, I think this is on, and I'm going to turn it away so it sounds a little better. All right. If you go to buildkite.com and you're logged in, you get something that looks like this. Let's go to the Julia Lang repository, where there's a bunch of repositories here. And if you click the little plus button, then you can set up a Git repository that you have access to. It'll give you a little list here, say the base benchmarks, and you can fill out all the necessary pieces of information. And what you'll end up with is something that looks like, let's go back to the main pipelines and go to the Julia master Buildkite. This is the actual Buildkite interface for Julia. And in the settings, you can configure all sorts of things, such as the very first steps that run your CI. And so this pipeline YAML is the steps that run when we first launch a build of Julia. And we're going to be going into a little bit more of how you use these YAML steps, and in particular, how you can use pipelines, pipeline plugins to add modular pieces of functionality to each step.
Right, so Elliot talked about plugins, and let's explore that a little more, yeah? So what are plugins really, right? So plugin is nothing more than just a set of bash scripts, but depending on the name of the script, it's defined to run at one particular point in the timeline of a whole build, right? And all of this stuff is available on the Buildkite documentation, so I'm not really gonna read out each one of them. So a plugin is somewhat analogous to what a GitHub action might be that you sort of add on to your GitHub pipelines, or how GitLab's plugins work, right? So one benefit, which is also sort of a double-edged sword that comes with Buildkite, is that the plugins are very, very flexible, right? They let you do whatever you want at whichever point you want, because you're literally just running bash scripts on your agent. And plugins can also be composed, in the sense that if there are multiple plugins, depending upon the order in which you define the plugins, at that particular point in the timeline of that job, that the plugins' respective commands or pre-commands or whatever hooks get run, right? So it goes without saying that we know what plugins are, we know what scripts are, so we have also developed plugins for ourselves. If anyone's ever seen a Buildkite workflow that for something Julia related, you probably already know that there's one Julia plugin and there's also one Julia test plugin. So the Julia plugin basically just installs a version of Julia, and the Julia test plugin just runs Julia tests with the installed version, right? So those are basically our entry-level plugins, which we haven't covered here. So we'll be talking about a bit more of the advanced plugins, like Forerunner, which lets you selectively run workflows depending upon the files that have been changed. YDT, which allows you to do templating with plugins, with pipelines, so you don't have to repeatedly write the same thing over and over again or have 10 different YAML files to keep track of, and it gives you a single source of truth. Sandbox, which lets you run things in a safe, contained manner. Cryptic, which lets you deal with secrets on Buildkite itself. Jack, which lets you deal with JLLs from the whole binary builder part of the ecosystem. SSH agent, that lets you clone private repositories when you're running it in the context of organizations and your repositories are in public. Tracy, so for those of you who know, Tracy is something that's been slowly making its way into the Julia compiler itself with instrumentation stuff. So the Tracy plugin could also give us insights onto performance and profiling and things like that. And then there's also Coppermind, which memoizes steps so that steps get run only when inputs get changed. So all these plugins help us develop more efficient pipelines, pipelines that run only when you really want them to, right? And we'll be talking about almost all of these plugins now. So let's start with Forerunner. So Forerunner is your equivalent, I would say, in GitHub Actions. You know how that you can specifically say that only when these paths change, I want to run these plugins, right? Because especially when you're dealing in cases where you have large mono repos and such, you run into an issue where all your pipelines are running when they don't need to be, right? So you want to be running your pipelines exactly only when you need to, and you want to have a high level of control and fidelity over that. So Forerunner ideally takes 4 parameters. The first is an array of file patterns, that is files that it needs to look out for. And then there's the path processor, right? So whatever files that match this pattern gets fed into the path processor, which is what determines if the target should be triggered or not. The target is typically a pipeline, that is a .yaml file, or it's a bash script or whatever script, right? And the target type defines how this target is going to be triggered. If it's simple, the target is just a simple Buildkite pipeline upload step. If it's a template, then one specific keyword called a path is made available to the target pipeline, which you can sort of just, which gets embedded using sed, right? That's an internal detail. You don't really need to worry about it, but yeah. And then there's command, which runs a particular command which is defined in the target, which each of the matches that you find. And there's a group command which just runs the target itself just once with all of the matches. So we could just really quickly show you Forerunner running. So this is sort of going to be an interactive thing where we will show you as you go along how what this would look like in your pipeline, right?
Do you have a pull request open already?
No, I think yeah, just go to the build. I think it's blocked. Yeah. And run the Forerunner. Maybe you should just show the script itself.
Yeah.
So for instance, let's consider this one case, right? This is a mini mono repo case where your repository has a lib directory, which is what we used to do before package extensions that Christopher talked about came about. And inside the lib, you have mylib1 and mylib2. So obviously, you don't want to run all your tests all the time, right? So we'll sort of explore each and every type of command. So first off, we have the simple one, which is just running your Julia formatter job. Let's say I change my project.toml. I don't want to be running a formatting check for that, right? Because PKG does that for me. Why should I care? So for that, what I would just do is I'd just watch every single Julia file. I target a simple format job pipeline, which is just run a formatting check. And that's a simple target type. Similarly, let's say I want to run package tests, right? Package tests are critical. I think all of us can agree about that. But I want to run that only when a package changes. I don't want to run it anytime any random file changes, right? So what we do is we define a path processor that detects if what the files changed belong to a package or not. And if so, you run tests only for the packages that changed. And we do that with a template thing. For the command and the grouped command, we sort of have just dummy examples that just illustrate what you could probably do with it. For instance, with the command thing, let's say I want to run for each file that gets updated. Let's say I have artifacts that get generated, and I want to upload this data someplace, right? And I had to do that individually for each of the artifacts that get generated. For that, I would use something like a command thing. Group command, I've just left it to be a bit more generic, and it's group command complex.sh because You won't typically run into this case until and unless you have very, very complex workflows wherein you have interdependencies between your monorepo packages, or say you have multiple levels of conditional checking that you need to do before you actually kick off your pipelines itself, right? I think the pipeline should have started by now. So, yep. So now you see we have triggered pipelines for the package test and for the formatting thing. So I had a dummy change in which I modified both the libraries that I talked about, and because of that, we have formatting changes that run because Julia files are modified, and we have package tests running for package 1 and package 2. Now this is great, right? And you could probably do this with a matrix as well, to try and find out which packages these are. But the maintainability of the pipeline itself starts getting so tricky. And so this sort of works out great for us because we have good level of control over what changes and what doesn't, right? But if you notice, the first thing that you notice is that you don't know which package test ran. You know that package test ran, but you don't know which package. So for that, we have YTT. And this is sort of a base primitive example of what you can do YTT for. YTT is sufficiently advanced, and YTT was developed by the folks at Carvel over at VMware to help manage different configurations for Kubernetes and all that, right? So safe to say it's sufficiently advanced with YAML templating. So what we do is with YTT, we can just template the name as a beginner example. So you know that which package is being tested, right? So I'll just use a forerunner command type target, and then I have a templating script that uses YTT, and then I'll upload the templated script over to Buildkite. So Buildkite knows how to pass this as well. So if you see that real quick, I think that should be started as well. Now with YTT and the templating stuff, we have it showing up as mylib1 test and mylib2 test, which gives you as a user a lot more visibility into what's happening with your pipelines. And you can also do a lot more cool stuff with YTT, like overlaying things into YAML files, with conditional stuff into YAML files. And all of this just really ties in together very well, especially when you're dealing with things like having to support multiple architectures and such.
Yep, so just to give a little bit more understanding, YTT is this binary that allows us to do templating in files with very easy syntax. And so these truly templated package tests, which is one of the files in here, it has things like these kinds of comments, which allow us to actually template things into the files at pipeline execution time, which is really useful for these kinds of dynamic workflows. All right. Next up, one of the most popular pipelines that we've written is the sandbox pipeline. It uses the sandbox.jl containerization engine that we wrote in the Julia ecosystem. And the tagline here is basically Docker, but nestable. And the idea here is that you have a rootfs image, which is a tarball that contains your entire environment that you want to be completely reproducible from run to run. You have a tree hash that identifies it. And then all the commands from there on run inside of that sandbox. Don't ask us how the rest of the commands run inside there, because Buildkite does not have this capability natively, but through the use of glorious hacks, it does. And so this is basically how Sandbox was born, right? We wanted it to work on everybody's machine, so we just shipped the entire machine. Now, as a fun little side note, the way that our Buildkite runners actually work is inside of a sandbox. And this is why nesting is so important for us, because our sandboxes that run our pipelines run inside of sandboxes that live on the Buildkite machine. And when we want to test the sandbox package itself, we run sandboxes inside of sandboxes inside of sandboxes. As a bonus picture, here's Valentine showing the actual hardware that all this runs on right here at MIT.
The hardware is also in a box, in case you
Another plugin that we've developed is called Jack. Jack goes with our JLLs, Jack and Jill, and Jack basically takes JLLs, downloads them, applies them inside of your sandbox or whatever environment you're running in. The default environment that our runners give to pipelines is actually quite bare, so you usually need to install something or use some kind of rootfs that has the tools that you want. And the beauty of Jack is that it downloads the JLLs and caches them inside of the depots that are already being cached by the rest of the CI ecosystem, so JLLs can be downloaded and used very quickly. So in this case, we have an example where, for instance, we download ffmpeg and make, and we can specify the version of make, and then we can run them and see the version of them and such. So if we were to quickly look at the pipeline here that we have, we unblock the sandbox and Jack demos to get them to run. And what we'll see is that Jack will download our JLLs. It will run run like ffmpeg-version or make-version or something. And we'll see that we do, in fact, get the software that we're interested in. I see I should have spun up more special JuliaCon runners to get these things to run a little faster, but oh well. So here it is. The sandbox plugin is downloading the rootfs image. It's unpacking it on disk. It replaces /bin/bash to get it to run in the sandbox as we need it to. And we get things like, here it is running GCC inside of a sandbox that actually ships GCC. And here we have a command that's, oh, here we go. That's installing XZ via JLLs. Oh, so it's a little bit different than what we had on this slide, but that's fine. And so all of this stuff just gives you the ability to install things reproducibly so that nothing ever changes out from underneath you and your CI doesn't break for no reason. All right. Finally, the most complicated pipeline that we're going to talk about today is Cryptic. So Cryptic is a way to deal with secrets inside of your pipelines. This is really challenging, especially if your pipeline is public and your agents can run things from anywhere. There can be drive-by PRs that say things like echo, $secret key somewhere in your build script. And so we've put a lot of effort in the Julia ecosystem, especially for base CI, for restricting access to things like S3 keys, code signing certificates. Actually, that's about it for the base Julia pipeline. And the way that Cryptic works is that it establishes a chain of trust from the very first job that runs, that thing that we showed in the web UI, the Buildkite web UI. And then each pipeline that should have access to secrets has to be signed. And so what you'll see in our demonstration repository is that if we take a look at the Cryptic example, there's a pipeline.yaml and a pipeline.yaml.signature. And the idea here is that the thing that launches this pipeline will check to make sure that the tree hash of all the files that are involved in this pipeline are the same. And if they are, then it provides the secrets from this job to the next job, and then from that job to the next job, for every job that needs to have access to those kinds of secrets. And jobs that don't have access to those secrets, doesn't matter. They don't have to be signed. They can do whatever they want. If they try to read an encrypted environment variable or an encrypted file, they just get the gibberish that is committed to the repository. And so as an example for the user-facing API for these kinds of things, the way that you would make something like this YAML file is the first thing you do is you create a repo key in your repository, and that creates a public and private key pair, encrypts those keys with the key that belongs to the agent. So we have a public key for the agent that you can use to do this encryption. It stores that into the repository. And then you can do things like say, I want to encrypt a file. And because it already has that key sitting there in the repository, it can encrypt the file, store it into the file. It says, put this little YAML snippet in the bottom of your YAML file, and you'll be able to read that file. And then when you run the job, you say, I have this file that is encrypted, so you list it in Cryptic here. As long as everything's set up properly, it'll decrypt it before your commands run, and then you can just cat out that file and use it however you like. So in this case, in this case, this is up here at the top, this showcase secrets decrypting, and Cryptic itself prints out useful little messages here that say things like, oh, I know that let's make this a little bit bigger for you guys. I know that I'm supposed to decrypt this file. I know that I'm supposed to decrypt these environment variables. And then the proof here is that we have actual useful text here rather than just encrypted gibberish. And so we use this extensively in the Julia and pretty much any pipeline that needs to do things like upload things to S3. And we try to make it as unobtrusive as possible by only encrypting the job that actually like uploads something to S3. So if you have something that, say, downloads something, builds it, we then upload it to the Buildkite artifacts, which is like temporary storage. Then another job, which is the actually signed one, will download it and then re-upload it to S3. We have like 8 minutes left.
Yeah, so we have like 8 minutes left. So I'm just going to really quickly walk us through a complex pipeline case study. And this is something that you can sort of do with all of the plugins that we discussed, right? So let's consider you have a Julia project that's monorepo, but with a root level package as well, right? For those of you who know kernel abstraction.jl, before package extensions, something similar to that, but with a twist wherein the root level package depends on the and vendors in the libraries. So the question here is, what do you want to run, right? At the base level, you know for sure that you want to run Julia tests, of course. And the next question that comes up is, when do you want to run what you want to run, right? I want to be able to run library tests only when I need to. I want to be able to run the root level package test only when the library tests pass, because my root level package depends on my libraries. And I only want to run these root level package tests on the version of Julia for which all the library tests pass as well, right? Because I don't want to be running tests on a version of Julia that I know it's going to fail for sure, right? I want to also be able to rerun tests, including the root level package tests, if they fail because of all these cache issues and such, right? And I also want single source of truth pipelines, because I don't want to have the same pipelines over and over again in my repository. So something like this, something this complex, can also be easily accomplished with the plugins that we have discussed so far. For instance, you could just use Forerunner to decide when your tests run. You could have single source of truth pipelines with your YTT plugins. You could be able to rerun tests by defining specific hooks that track if tests have passed or failed and such. You could run root level package tests when library tests pass on specific versions of Julia. Also, again, using hooks that ensure that previous versions of tests that were run on different versions of Julia for the library test pass, right? So that was quicker than I want to run through it, but we are short on time. So, and quickly, we also have a pipeline gallery. So these are some of the biggest or the bigger projects in the Julia ecosystem that currently use some or all or a lot of the plugins that we've discussed so far. So yeah, that's been our time. Any questions?
So I wanted to ask, because for other Julia organizations, if it's possible, there is a discounted pricing some other support resources from Buildkite.
So Buildkite has historically been pretty friendly to open source projects. So as long as your like repository and everything is open source, they can usually cut some kind of deal, like allow you to create pipelines and have as many agent minutes and such as you want. In terms of like hosting of agents, is that what you're asking about?
In terms of just any services, products that are provided by Buildkite.
Yeah, I think at least for the Julia language project, they've allowed us to create as many pipelines as such as we want. For like open source ecosystem projects, we're pretty happy to, if you want, just have your project inside of like some organization, sub-organization, or even the Julia Lang organization, as long as it's kind of like a ecosystem project, and even run on RCI as long as the load isn't too high.
Thank you.
Anyone else?
Yeah, down here.
And
Right
down
behind
here,
you.
down here.
Oh.
So there was a bit of mention about like how Sandbox runs and how things connect for like the MIT Julia deployment of whatever's running the agents. do these like plugins and stuff you've developed, do you see this operating well in like a cloud environment if someone wanted to deploy the code to run these agents and these plugins? Or is it sort of modeled after you have a machine or a set of machines and you're going to install what's required on there?
That's a great question. So there is one package that requires a particular agent setup, and that is the cryptic plugin. It has pretty specific requirements, and that's all laid out in the README. All the other plugins don't really have any necessary things, and they do their best to like automatically download binary dependencies if they need them already. The only thing I would say is the Julia plugin typically expects to have an environment variable defined, telling it where it's going to cache its depots in like a persistent location. As long as you set that, most of our other plugins hijack that and store all their stuff inside that same location, you know, as artifacts or whatever. And so as long as you've done that, this should work pretty much anywhere. One more in the back.
Oh, yeah, two more.
Two more. All right.
There's one there and another there. We had two more questions.
Thank you. Could Forerunner also watch for changes in dependencies?
No, so that's a good question. So Forerunner, the changes it detects, it only looks at the files. It considers the git diff of the files that have changed. Yeah. And depending on the context in which it's run, its behavior differs slightly. For instance, if you're running Forerunner on a commit that was pushed to a branch which does not have a PR open, it considers only the changes in that particular diff for that particular commit. But if you're talking about the pull request, it considers it from the base branch to which the pull request is directed.
Okay.
And so as long as the dependency that you're talking about is in that same repository, yes. But if it's something far away that you have to download, no, it doesn't consider that.
There's no question there. There.
That's pretty long, but why Buildkite, not a different one? What's like this one thing perhaps that maybe Buildkite versus other offerings?
Yeah, so for the purposes of base Julia CI, the most important thing is platform support. And so we need Mac, we need Windows, we need Linux, we need FreeBSD, we need all these different OSs and architectures. So that narrows it down to basically Buildkite or Azure pipelines at the time that we were looking. The reason why we chose Buildkite is because we liked the flexibility of the plugin architecture, actually. And as you can see, we've abused it horribly, as we are wont to do.
Also, in the issue that Elliot mentioned in his first slide, you can also read up more about it as they were evaluating different options and all that as well. It's 37341.
Yeah, and to be clear, the landscape has changed somewhat since we first posted that, but most things still hold true.
Also, it goes without saying that if any of you are looking to move to Buildkite or need help migrating over to Buildkite, feel free to reach out.
Yep.
Happy to help.
Thank you all.
Thank you.
Thank you all very much, too.